Hey there. Today's video is a continuation on how to prove a sequence of real numbers is eventually in a set. In the first video on this topic, which I'll provide in the description, I slowly build up to the formal proof as I felt it was important to first motivate what we were trying to accomplish. What differs about this video is that I will be moving at a considerably quicker pace, so I strongly suggest reviewing part 1 as a warm-up if you haven't already. I will, however, elaborate when I feel it is necessary, of course. And with that said, let's begin. The example we will be working with today is the following. For each little n in the natural numbers, let the sequence a sub n equal to 2n minus 3, all divided by n. Then the sequence a sub n indexed from 1 to infinity is eventually in the interval 3/2 and 2. And the definition we will want to use once more is the following. A sequence a sub n of real numbers is eventually in a set A if there exists a capital N in the natural numbers such that for every little n greater than or equal to capital N, our sequence is in the set A. So let's look back at our example and try to identify what the set A is. We're told that our sequence is eventually in the set 3/2 and 2. So let's call that A. And now we can begin determining the capital N in order to complete our proof. To do that, let's first look at the real line with the interval 3/2 and 2 with a few elements of the infinite sequence a sub n. Remember our sequence was 2n minus 3 divided by n. So let's list out the first 4 elements and see what's going on. If we plug in 1 into the sequence, we'll get -1. 2 will give us 1/2. 3 will give us 1, and 4 will give us 5/4, which we could write as 1 1/4 in decimal form. And let's plug this into our interval. Our set A, recall, was 3/2 to 2. And if we start plotting the elements of the sequence a sub n, we'll find that a sub 1 is right here. A sub 2 is 1/2, so it'll be right here. A sub 3 is 1, and a sub 4 is roughly right here. And notice that our sequence is increasing. It's moving from left to right. What we want to know is which value of n will cause us to move inside of this interval A. And another way to put that is when will a sub n be strictly greater than 3/2? Another way to write this is as follows. 2n minus 3 divided by n is greater than 3/2. So the strategy at this point is to try to get the little n on the greater than side. And we can do that by first cross multiplying. Which simplifies to, now moving this 3n to the left hand side and the 6 over to the right hand side, we'll get 6. And this simplifies to n is greater than 6. So since the inequality demands that we choose a natural number greater than 6, let's just choose our capital N to be 7 and move on to the proof. So here we'll write capital N is equal to 7. We can open the proof by first stating the natural number capital N that we just found. So let capital N equal to 7, and suppose that for each little n, we get that little n is greater than or equal to capital N, which we just said was 7. We want to show that the infinite sequence a sub n is eventually in the set 3/2 to 2. So notice we could use the inequality n is greater than or equal to 7. And what our strategy now at this point is to try to get the sequence a sub n on one side of the inequality. We'll do that by first multiplying both sides by 2. Subtracting a 3 from both sides. And then dividing by n. And notice that we have our a sub n on the left-hand side of the inequality. And on the right-hand side, we could claim that this is strictly greater than 3/2. But why is this true? Let's direct our attention to this inequality in the box here. Now, you don't have to include this in the proof. This is just an explanation. Notice that if we let our little n equal to 7, then what we get is, and after cross multiplying we get, which is true, 22 is greater than 21. And we can now pick up where we left off with the proof. Since we are convinced that this is in fact true, that this is greater than 3/2, we could claim that our sequence a sub n is greater than 3/2. And we could write our concluding sentence here. Hence, for all little n greater than or equal to 7, we have that the sequence is strictly greater than 3/2. That is, the infinite sequence a sub n is indeed eventually in the set 3/2 to 2. And we conclude our proof here. I hope this video has been helpful, and thank you for watching.